Okay, let's do the part 1 of Algebra Final Review. Here we have this Google form. Just in case while you're doing this, if you need to make it larger so that you can see the details, you can use Control and plus to zoom in on your browser. Control plus. And if you just want to go back to the normal size, you can use Control and the subtract sign to zoom out. All right, let's go on. Let's go with question 1. Question 1. What is the value of x in this equation below? So we have this equation, and to do this, we need to first, let's combine the similar terms. 3x subtract 10x, that's 3 subtract 10, that's negative 7x, okay, plus 5 equals 5x plus 17. Now, second step, to solve this, we want to separate the terms with x and the pure numbers. So we will try to move this 5x, move it to the other side. Remember, when we move it, it has to flip. It has to become negative 5x. So let me write it down. Negative 7x. This will become a negative 5x. So flip it. Copy the plus 5. Copy the equal sign. On the right, we have just a 17 left. So we have this. And now we combine the similar terms. Negative 7x subtract 5x. This is going to be negative 12x. Just combine these two terms. Plus 5 equals 17. And lastly, we want to separate this 5 to the other side. So we are going to move this 5 to the other side. Remember, when you move it, it will flip the sign. Therefore, we will have negative 12x equals 17. Here, this one will become a negative 5. 17 subtract 5. And then this is 12. So we have negative 12x equals 12. Negative 12x equals 12. And lastly, we do divide. So we divide by the multiply of x. X is multiplied by negative 12. We divide by negative 12 so that they will cancel. Okay, we do the reverse, the backward of multiply. That's divide. Multiply by 12, divide by 12. They will cancel. We do the same thing on the other side. These will cancel. Therefore, we have x equals 12 divided by negative 12. That's going to be a negative 1. Negative 1. So the answer will be x equals negative 1. Right? That's the answer. Question 1. X is negative 1. X is negative 1. Okay, let's go on to the question 2. Let's go on to question 2. Question 2. What is the solution for the inequality below? We have this inequality. To answer inequality, to begin with, we can just regard it as an equation, and we do similar steps to the equation. If you have a parenthesis, like you have the terms packed inside the parenthesis, the first step you want to do is to unpack. So we want to unpack this and unpack this as well. When you unpack, what you do is the outside term will multiply each term inside. Okay, that's to unpack. So first, 3 multiplied by 2x, that's going to be a 6x. And 3 multiplied by negative 1, that's going to be a negative 3. After unpack, we have 6x subtract 3 to the left, and copy the same the smaller than the sign, and unpack the right side. Similarly, the outside 2 will multiply each term inside. So that will be 2 times 4, that's 8. Then 2 times 3x, that's 6x, right? After unpack, we have this. After unpack, we have this. Now, we want to move the x to one side, and we move all the numbers to the other side. First, let's move the 6x to the other side. The 6x to the other side. Remember, when you move it, it will flip. It will become a negative 6x. So we will have 6x. This will become a negative 6x. Then copy the rest. Negative 3, copy the rest. Okay, we move it to the other side and flip the sign. Now what we have is 6x subtract 6x. They will just cancel each other, so this will be just 0. Okay, 6x subtract 6x, it will be 0. Then you have just, this is 0, so we have just negative 3 is less than 8. So we are left with this inequality. Let's check. Is there a solution, or how many solutions does it have? So negative 3 is less than 8. That's always true. That's always true. That means for any x, no matter what value is x, negative 3 is always less than 8. So that for this inequality, it's always true, regardless of what is the value of x. So the solution will be for any value, for any value, for any value of x. The inequality is always true. It's always true. Therefore, we will say the solution is all real numbers. All real numbers, right? So the solution will be D. Okay, all real numbers. For any number, for any real number value of x, the inequality is always true. So the solution is all real numbers. Okay, that's for question 2. Now let's go to question 3. Question 3. Crystal is adding an in-ground pool to her backyard. The dimensions of the pool are shown below. So we have this pool, and the length is 5x subtract 1 units, and the width is 3x plus 2 units. Find the perimeter of the pool in terms of x. So to do this, we first need to know what is how do we get the perimeter. Perimeter is the length and the width, all the 4 sides add up. So we just need to add all the 4 sides up. The length, this length, 5x subtract 1. And we also need to add this length. They are the same, so we just add it again. Add another 5x subtract 1. And they add up. This is going to be 5 plus 5x. This is 10x. Subtract 1, so it's subtract 2. The two lengths add up to 10x subtract 2. Now let's add up the width. For the width, 3x plus 2. That's one width. And we have to add the other width. That's another 3x plus 2. So that's going to be 6x plus 4. This 3x plus 3x, 2 plus 2, 6x plus 4. And lastly, we just want to add the length and the width, all of them add up. 10x subtract 2 plus 6x plus 4. And that will be 16x. This is 10x plus 6x, 16x. And negative 2 plus 4, that's a positive 4. So that will be 16x plus 2, right? 16x plus 2, right? Okay, so the answer will be 16x plus 2. Good. Let's go on to question 4. Question 4. A quadratic function is shown on the graph below. What are the domain and range for the quadratic function shown on the graph? Well, we didn't learn about quadratic function. We only learned about linear functions so far. However, we learned about the domain and the range, right? So domain is all the possible values of x, and the range is all the possible value of y. On this graph, we can tell for the domain, that's for the x, we can tell this x start from here, right? Start from here and goes to the right. And here you can see this graph doesn't stop. It's still extending. So we can say the x will also goes on to the right and goes on. Therefore, we can say the domain will be from here. This is a negative 0, negative 5, negative 10. This is negative 8, right? So domain is from negative 8 to infinity. So our x will be greater than, but this is solid, so x can be equal to negative 8. So x will be greater than or equals to 8, and then forever. So there's no limit on the other side. There's only one limit, that is x should be greater than or equal to negative 8. That's a domain. Now let's check the range. For the range, that's the y value. From here, the y value is here. Now when it goes up, the y value, the range, this is the range for the y value. However, the whole graph is going down again, and then after this point, we have the x values below this point. Therefore, you can tell it will go down and down without stop. Therefore, the range will be from this point, and down, or y is less than, because we have a solid point there, so y is less than or equal to that value. And that value should be, let's check the options. We know domain is larger than, greater than or equal to negative 8. So this is, A is wrong, okay, this is wrong. And the C is wrong. Therefore, we have B and D. They have the correct domain. Let's check the options for the range. For B, it says domain, the range is negative 6. This is 0, negative 6 should be around here. That's B. For D, it says y is less than 6, less than or equal to 6.5. That will be positive. So if we pick B, that's a negative 6. However, from our graph, we can tell that the range, the limit is absolutely above 0. It should be a positive. So negative 6 is wrong, okay? Negative 6 is wrong. Therefore, the only possible answer will be D. X greater than or equals to negative 8, and Y is less than or equal to 6.5. We choose D by eliminating the other options, right? So the answer will be D. Okay, let's go on to question 5. Given the graph below, which of the following represents the domain of the function? Domain, we know that domain is all the possible x, right? So let's check the x. On this graph, the x starts from here, that's negative 6, 4, 6, 8, yeah. Starts from negative 6. As the graph goes to the right, the domain goes to the right. And goes to, it stops here, and that x is 8. So from negative 6 to 8. However, you should also notice the negative 6 is solid, so x can be equal to negative 6. But this 8 is empty, okay? This 8 is empty. That means x is less than 8, but cannot be equal to 8. So the x will be greater than and also equal to 8. Negative 6, because that's a solid point. And x is less than 8, and it won't be equal to, because that's an empty point. So this is a domain. And based on this, our choice will be C. Okay, this will be the domain. Alright, let's go to number 6. Which set of points would not define a function? So we know for a function, the definition is for each input, one and only one output. Okay, and that's the rule. And in those packs of numbers, the first one is the input, the second one is the output, or we can say for each x, there's one and only one y. Okay, so let's check for A, x, y. Okay, the first x is negative 2, y is negative 2. Second, y is negative 1, y is negative 1. Third, x is 0, y is 0. Fourth, x is 1, y is 1. And last, x is 2, y is 2. Now you can tell for each x, there's just one y, just one corresponding y. So each x has a y and only one y. And that means, yes, it meets the rule. So number A, it's a function. It is a function. It passed the rule. A is a function. Option B. Let's check option B. Negative 2 to 9, 0 to 1, 1 to 0, 3 to 4, and 4 to 9. Again, for each input, there's just one output. So B also pass, and B is a function. Let's check C. C, negative 1 to 0, 0 to 1, 0 to negative 1. Okay, this should ring a bell to you. For this same input of 0, it has two outputs, 1 and negative 1. And that breaks the rule. Okay? You can think of this as a fork. That is, this 0 goes to 1 and also goes to negative 1. That's a fork. When you see a fork, that's not a function. And also the rest, 3 to 2 and 3 to negative 2. That's also a fork. So this fork makes C not a function, not a function. So C is not a function. Okay, now we have found out the answer. The answer is C. However, let's just finish D. For D, -6 to 2, -5 to 1, -4 to 0, -3 to 1, and -2 to 2. Okay, so every input has just one output. Each input has just one output, and that pass. Therefore, C is not a function. C is not a function. So the answer will be C. The answer will be C. All right. Let's go to question 7. Question 7. The distance in meters from a basket suspended on a spring to a tabletop below is dependent on the numbers of steel bearings in the basket. The function representing this relationship is d of m equals 7 subtract 2m, where d of m represents the distance in meters and m represents the number of steel bearings in the basket, which set represents the evaluation of the function d of m when m belongs to this set 0, 1, 2, 3. Okay, this is a very long description. However, basically it just means, say we have a function. We have a function. Or let's say a function machine. We have a function machine. And we call it D. This D takes in M as an input, so it's called the D of M, the function D of M. It takes in M. And then the rule is 7 subtracted 2m. Okay? And they are asking for, if I input different values of m from 0, 1, 2, 3. Okay? If I put in 0, what do I get? If I put in 1 as m, what do I get? If I put in 2 as m, what do I get? And if I put in 3 as m, what do I get? So basically, we just need to evaluate for m equals 0, 1, 2, 3. Now let's do it. When m is 0, the machine will do 7 subtract 2 times 0. That's still 0. So 7 subtract 0, that's a 7. Next, let's evaluate for m is 1. When m is 1, the machine will do 7 subtract 2 times 1, that's 2. 7 subtract 2, that's a 5. When m is 2, we will evaluate. The machine will do 7 subtract 2 times 2, that's 4. And 7 subtract 4, that's 3. And lastly, we do m is 3. The machine will do 7 subtract 2 times 3, that's 6. 7 subtract 6, that's 1. And the collection, the set for the result will be 1, 3, 5, 7. Okay? This will be the collection. This will be the collection. The collection will be 1, 3, 5, 7. Therefore, the answer will be A. The answer will be A. 1, 3, 5, 7. Okay, let's go on to question 8. Question 8. A representation of a linear equation in two variables is graphed on the coordinate plane below. This is a linear equation. What is which linear equation in two variables can be used to represent the line? So we're going to write out the formula for this line. And we know that to write out the formula for this line, we have two choices. Either we can use y equals mx plus b, that's a slope-intercept form. Or we can use y subtract y1 equals m subtract x, m times x subtract x1. That's a point-slope form. So we have two choices. Which one do we pick? That depends on can we easily find out the b, all right? Now, yes, we can. We can actually quite easily find out b, right? The 0, 5, this, I guess this is a 8. I guess this is 8 because I'm guessing negative 8 because I'm guessing probably it's this one, negative 8. So I'm guessing this is negative 8. Let's say, suppose this is negative 8. So we can find the b. Now let's do the slope. Let's do the slope. For slope, we need 2 points. We have 1 point here, 1 point here. This is negative 5, so this should be like a negative 6. Negative 6, 0. This one is 0 and a negative 8. This point. 0 and negative 8. Okay? And when we do the slope, let's mark x1, y1, x2, y2, and use the formula y2 subtract y1 over x2 subtract x1. That's a formula. So let's do it. Negative y2, negative 8. Subtract y1 is 0. Over x2 is 0. Subtract x1 is negative 6. And the negative 8 subtract 0, that's negative 8. X subtract negative 1. When you have like 0 subtract negative 6, 0 subtract negative 6. When you have subtract negative, those two bars side by side, imagine that we just put them across. They will make a plus. So this will become a positive 6, all right? So if you have two bars, subtract negative side by side, put them across, they will make a plus. So this will be a positive 6. And that will be negative 8 over 6, or that's negative 4 over 3. Because we just divide by 2 on both top and bottom. That's 4 over 3. So that's the m. That's a m. That's a m. Let's write down. M is negative 4 over 3. B is negative 8. And put into the formula y equals m and negative 4 over 3 times x plus b. B is negative 8, so plus negative 8, just negative 8. Okay? And that will be option B, right? Option B. That will be option B. And they are using option C as a distraction. See, if you don't put the x and y in the correct order, and you put them upside down, you will be tempted to choose C. And however, the answer should be option B. Okay, option B. Let's go on. Oh, that finish part 1 of the algebra final review. Right, so we're going to stop here. That's the part 1 of the final review. Right.